So first and foremost, what are intents? You've probably heard about intents on crypto Twitter, in particular, uh, different types of products and bridges. Obviously, bridges are one of the most used protocols within DeFi. No matter what opportunities there are, across all of the ecosystem, you need a bridge in order to access them. Of course, you can use a centralized exchange, but at least if you're an on-chain DeFi native, you're using a bridge. Typically, bridges have been, you know, a wrapped version of a token is what's getting actually bridged. Uh, there's plenty of bridges that work like this, and then there's also liquidity pool bridges. However, there's intense bridges where a user simply has one token on one chain and they want another token on another chain. That is the intent. Now, what actually kind of facilitates the intent is what is known as a solver, and that can mean the actual transfer of assets between chains. It can mean swapping from one asset to another, and it can also mean things like executing a smart contract call on the destination or on the source side of the bridging transaction. To give you some examples, some intense bridges you might be familiar with are a cross or D bridge, and some bridges that aren't intense based, for example, Circle CCTP, which utilizes a burn and mint functionality similar to Wormhole's NTT, and then Stargate, which is a liquidity pool model. Of course, on the intense side, there's a few. Of course, there's a cross and D bridge, and there's a few others, but that's kind of where Settlement is wanting to focus, is not on the not intent sides, but more on the intent side, because as we're finding out more and more, users and individuals are prioritizing speed above all else. And the main reason for that is because the user experience is a whole lot better by doing so. That is kind of where Settlement or Wormhole Settlement comes in. It's instead of it being specifically an individual product, it's more, I would consider it more of like a suite of products. Settlement refers to Wormhole's kind of intent infrastructure or intense bridging products. However, it's split into three separate categories. Now, the first one is what is known as Mayan Swift. If you've used, for example, Phantom Wallet or Backpack Wallet, as well as a few others like Rabby and MetaMask, odds are, if you've done a bridge within that wallet, you've used Mayan Swift. Which, of course, if you're familiar with the Mayan Finance team, is a product that is built using entirely Wormhole technology. The second kind of stack in Settlement is the liquidity layer. Now, the liquidity layer utilizes a very unique architecture that intense bridges typically do not use or haven't used up until now, which has led to a hell of a lot of improvements as far as volume and scalability is concerned, which also are actually the biggest bottlenecks and obstacles for intense-based bridges, but I'll get into that a bit later. And then finally, we have MCTP, which is how I describe it as almost like a wrapper around CCTP that unlocks a hell of a lot more functionality. You can go from any asset to any asset. You can initiate smart contract calls on the destination on the source using arbitrary payloads and a few other things as well. And I kind of think of this as more of like almost a I don't want to say redundancy necessarily, but of course there are use cases, there are users that don't really care about speed, and they want something that uses as little fees as possible, and they're happy to wait finality if they're sending from Ethereum. In which case MCTP kind of satisfies that kind of user need. Now, Mayan Swift, like I mentioned, uses the typical intense architecture where a solver. So you've probably heard of names like Rockaway X, like Flow Traders, like Wintermute, as well as a few others. They're typically market makers, but they'll also be doing solving for intense bridges. Now, how this works is that you will have liquidity on multiple different chains, what we call inventory. And that inventory can usually take form in gas tokens as well as stable coins. Basically things that have very, very deep liquidity and will be able to facilitate a lot of volume and transactions without seeing much slippage or price impact. How this works is you will have liquidity on these different chains, and when a user wants to actually bridge between one chain and another, what will happen is, let's take an example actually. What will happen is the user will first initiate the order, which will go to the actual bridge contract saying that, hey, this user is sending over 1,000 USDC, for example. please release 1,000 USDC worth of money, worth of tokens on the destination chain. And so how that happens is typically we'll have, just to get a slight bit technical, if we use this example of a user has ARB on Arbitrum and then they want WIF on Solana, what will happen is, from the user's perspective, they're going from the ARB token to the WIF token, and that's the end of the transaction. And this all happens, within 5 to 10 seconds. However, what is happening on the back end is that a solver will have a liquidity pool or inventory on Arbitrum. They'll also have inventory and liquidity on Solana. And so what that means is they will use specific assets to kind of transfer and store value. So in this example, the solver will not have inventory of ARB and they won't have inventory of WIF, right? They're altcoins. They don't necessarily have the best liquidity. And if you wanted to go from another token to ARB, it might be harder. So what they do instead is that they will have inventory of Ethereum, of ETH itself, which will have the most liquidity and the most depth, which will allow for the lowest pricing. They'll then swap that ARB into ETH and then accept it into the escrow contract. By doing so, this will basically initiate, will emit a VAO over the Wormhole network to the solver on the Solana side. The same solver, of course, but different contracts, different pools. And then on the Solana side, it will say, hey, this person has 1 ETH of assets that they've given us. Please release, $1,000 worth of SOL on the Solana side, which it will then do so. It'll then use an aggregator like Jupiter to swap that SOL into WIF, and then the user is transferred that WIF. But as you can probably see, there's quite a few steps involved, right? ARB gets swapped into ETH. That ETH is accepted by the solver. That escrow account, that escrow contract will emit a VAA, which will make the solver wallet on the Solana side emit that level, that amount of money that the user's requested in SOL, and then it's swapped to the asset that the user wants, and then is given to the user. And then, of course, the last step of that entire process is that when the user receives the tokens that they wanted, that in and of itself will emit a VAA, thus releasing the initial assets that were put into the escrow contract to the solver that fronted that liquidity. And the idea is, if the transaction reverts for whatever reason, or it's just not successful, the funds never go to the solver. They either remain in the escrow contract, or they, if in the event of a failure, then get redeemed and given back to the user. So that's the first architecture, which is the typical intense architecture, where you have inventory on multiple different chains, facilitating bridging between them. Now, there is, a very, I don't want to say problem, but there is a big cost associated with being this kind of bridge. And that is that, if we were to play this example out, 10, 100 times, what would happen is that, as you can probably tell, the Ethereum or the Arbitrum inventory is getting bigger and bigger and bigger, because all of the assets are going into it because they're bridging from Arbitrum to Solana. However, on the Solana side, their inventory is actually getting depleted. These, of course, they're giving the user the assets that they want. And so if you do that enough times, you'll reach a point where the Solana inventory has no inventory at all, no liquidity. And then on the Arbitrum side, they've got a huge glut of liquidity. And so what would happen in this case is a solver would then have to rebalance. And what that means is they will go to an OTC desk and say, hey, I've got this much on Arbitrum. Can you give me this much on Sol? Or alternatively, they'll simply use a centralized exchange like Binance, where the solver will just simply send their Ethereum and Arbitrum to Binance, swap it for Sol on Solana, and then just send it from their Binance account to the on-chain wallet. And then they can, if it's a small solver, they can be doing this manually. Obviously, if it's a larger solver, they can automate this process, but it's still extremely costly. And they have to actually wait for finality. They have to wait for just whatever transaction time it takes Binance to say, hey, the money's arrived. And so it's, I don't want to say inefficient necessarily, but of course, there can be times where you're not able to service a route because there just isn't any liquidity. Now, intense bridges are very good about managing this, and so you shouldn't really run into that kind of problem. But in times of very high volatility, it's bound to happen. And that's kind of one of the costs of intense bridging, is that you have to be happy with this. So we thought about that. And so then we released, or rather, as part of settlement, we have the liquidity layer. Now, the liquidity layer works extremely differently as far as architecture is concerned. If we go back to the Swift example, this architecture is excellent for speed above all else. I'll just look at the questions before I move on. What term is the speed of settlement of chains? Gotcha. Yep. Okay. I'll continue with the presentation, and you'll get your answers soon enough. So going back, you have inventory on multiple different chains. You can facilitate bridging extremely quickly and extremely quickly. However, there's a cost because it's not necessarily scalable, because you can't be, I mean, you can be rebalancing, but then again, it's not really scalable, it's costly, and it's annoying for the solvers in question. But this architecture is amazing for speed above all else. However, with liquidity layer, we have a very unique architecture in that we have no real bridge has used this up until now. Liquidity layer is the first form of this. Is that instead of having a point-to-point intense architecture, we instead have a hub and spoke model. And what this means is that instead of solvers having their inventory on every individual chain, they instead actually consolidate all of the liquidity on Solana. Now, what does this actually look like? Let me try to if I can zoom in. No, I don't think I can. Well, regardless, I'll use this example. Very similar to the other example where you go from arb to WIF. In this case, the user wants to go from arb to Joe on Avalanche, which is, of course, the #1 DEX on the Avalanche chain. Now, again, the user would give arb on Arbitrum, they'd receive Joe on Avalanche, and happy days, that's the end of the transaction for the user. They go on and do whatever they want to do. What happens in the back end, however, is that arb, again, I mentioned solvers needing to use a kind of facilitation asset or a shuttle asset that they have inventory of. This model is no different. However, in this model, all the liquidity is actually in USDC. Now, what does this look like? ARB in this example would be swapped for USDC on Arbitrum, which would then emit a VAA, would then be sent from Arbitrum to Sol, thereby emitting a VAA. Now, why do you need that VAA? When you make that transaction, what happens is that a auction will be started on Solana, where solvers will be able to bid on this transaction. And the way it works is that we start at a specific price, in the liquidity layer's case, around 4 to 5 bips, and then users are able to, solvers are able to come in, compete, and whoever's able to execute that auction or execute that transaction for the cheapest fee wins the auction. And the idea is that you have price discovery, you're able to have these solvers engage in competition in order to be able to solve the transaction, thereby making it as cheap as possible for the user. Now, once they do this, of course, Arbitrum is an L2, it's an ETH chain. It takes 15 minutes for that USDC to be sent from Arbitrum to Solana. So the solver that wins the auction actually fronts that capital. And so then again, over CCTP, they send that 1,000 USDC from Solana over to Avalanche, which finality, or at least Circle's definition of finality from Solana is around 12 seconds. And the user will then get that asset in around 12 seconds. It gets swapped into Joe, and the user gets their assets. However, on the back end, after that initial 15 minutes elapses, i.e., the amount of time it takes a CCTP message to be sent from Ethereum or an L2 to any other chain, because you have to wait for ETH finality. Once that 15-minute elapses and the CCTP message is received on Solana, it is then redeemed by the solver to basically receive the money that they fronted as well as the fee that was charged to the user. And so then this way, the solver doesn't actually have to do any rebalancing. If anything, the rebalancing is happening on a per transaction basis, with the longest wait time being 15 minutes if the initial transaction was executed from ETH or an L2. However, this way it's far more capital efficient. It's far more, efficient for the user, for the solver, in that they don't have to rebalance. But best of all is that you're able to facilitate far more volume, and you don't really have any downtime as far as like lack of liquidity is concerned. Now, of course, if the solver in question was able to distribute all of their funds from Solana, and they were just waiting 15 minutes for the CCTV messages to come through, yes, they would be out of pocket. They wouldn't be able to facilitate any new transfers. However, after 15 minutes, they would just get their funds again, meaning they don't have to go roundabout. They don't have to go to Binance and say, hey, here are my assets, please give me some. They just have to wait for CCTV message to be received, and the solver receives their money back. And of course, they're rebalanced. I'll answer a question before I move on. What specific functions do Wormhole Guardians perform during settlement, and how does their consensus model ensure reliability? So in both architectures, both Mayan Swift as well as the liquidity layer, we use the guardians more specifically to facilitate VAAs. So there's a few places where VAAs are actually omitted during this entire kind of, I don't want to say user journey, but contract journey. If we talk about the liquidity layer, the VAA that's emitted on a source chain, that is what actually initiates, or rather, the auction contract on Solana is monitoring the Guardian network for a specific VAA, which, if it sees it, will then execute an auction which allows solvers to be able to bid on it. Now, that VAA, of course, is sent from Arbitrum. It's read, it's propagated by the Guardian network, by the Wormhole network, and then it's read by contracts on the Solana side. So that's kind of how we use VAAs there. On the Mayan Swift side, however, we use VAAs in two separate places. One is the initial escrow contract receiving the user's funds, which will emit a VAA to the destination chain, or rather, emits a VAA to the Guardian network, whereby the solver contract on the destination chain would read that and say, hey, let me front capital and give it to the user. And then once the user receives that capital, that would then emit a VAA again over the Guardian network, whereby the escrow contract, upon reading that VAA, would then release the funds to the solver on the source chain. So I hope that that answers your question. I'll move on. Finally, we have MCTP, which I already touched on, but of course, it's effectively a wrapper around CCTP, where you're able to not only do, of course, USDC to USDC transfers, but you can actually do any asset to any asset using USDC and CCTP as somewhat of a kind of transfer rail. It's actually somewhat similar to the liquidity layer. However, there is no solver required for MCTP. Hence, you have to just wait for finality. So it's a hell of a lot slower, of course, but you're still able to actually get a lot of that functionality, i.e. the arbitrary payloads and the any-to-any swaps. So there's a few ways you can kind of use this, and it's already being used by many different protocols. I'll just stop sharing my screen and share a different screen. There we go. I'll answer the question: what criteria or considerations guide Wormhole's decisions to expand the liquidity layer support to new chains, and how quickly can this integration be practically achieved? So you might have noticed that I shouldn't say one of the architectures, but with the liquidity layer specifically, it uses CCTP as the fundamental transfer rails, right? Going back to that. Going back to this deck, this uses CCTP fundamentally, which means we are limited by the chains that CCTP is live on. We can only deploy the liquidity layer if the chain has CCTP in question. Now, of course, you can make the argument that most of the chains that are responsible for most of the volume, of course, have native USDC and they have CCTP. So the liquidity layer support is pretty widespread, at least as far as the most of the meaningful routes are concerned. Right now, it's live on every CCTP chain with the exception of Noble and Sui, but support for those is coming quite soon. One of the things, however, that was obvious is that, well, we can't really control where Circle wants to deploy CCTP and when, in which case we are actually working on, I guess, parallel rails, in that you don't have to use CCTP necessarily. You can actually use entity-enabled assets. And so entity, of course, is deployed wherever wormholes are deployed, which is over 30 chains. However, one of the reasons why we use USDC and, going back to the Mayan Swift, why we use an asset like a gas token is simply because we want as much widespread access as well as you want the best slippage. Because if you're using a shuttle asset that, like a gas token or a stable coin, it'll have the deepest liquidity, and so it'll have the least price impact if you're trying to swap in and out. Now, we can do that same thing with, of course, the liquidity layer, where we expand the support to support NTT assets. However, you would need those NTT assets to be live on certain chains, but then also you would obviously need meaningful amounts of liquidity. However, there are certain routes where there'll be one entity asset or two entity assets that are extremely deep in liquidity, or alternatively, they might be competing with USDC in some way. In which case, the way that settlement would work is simply routing through whatever gets you the best speed, as well as whatever gets you the best price execution. So I hope that answers the question as to what kind of decides. I don't want to say we have our hands tied necessarily, but we are limited by where Circle deploys CCTP, which is why we're building that NTT infrastructure within the liquidity layer so that we're not limited and we can effectively deploy this anywhere that Wormhole is live. Just going to share this tab. So of course, this is the product page for Wormhole Settlement. Fast institutional scale digital asset settlement. One of the things I didn't mention before is that one of the reasons why settlement came about is that as Wormhole has began working with more and more institutions, of course, like a Securitize, like a Apollo, etc., it became clear that there's actually no meaningful way to be able to send assets in size with scale quickly. You of course can use Canonical Bridge or use something like CCTP, but then you're limited by finality. Or alternatively, yes, you can go via centralized exchange or ask an OTC desk to front your capital. But if you want to do something purely on chain, quickly and in size, the only real way you can do it is, well, there really isn't any meaningful way up until now. And so settlement kind of came about to meet that gap in the market, because of course these players like Securitize and BlackRock and whatnot, they don't necessarily want to do things off chain. They want to do everything on chain. They want to be able to automate it as well, either with smart contracts or otherwise. And so settlement, specifically liquidity layer, is able to actually give that functionality. And the idea is that we have Mayan Swift, which is great for small transactions and where speed is the top paramount priority, where fees, etc., is less important. And then the liquidity layer is slightly slower than Swift. We're talking, instead of 5 to 10 seconds, it's 10 to 20 seconds. However, you're able to do ridiculous levels of size simply because the liquidity is consolidated. Because if we take the example of, let's say you have $10 million as a solver and you have 10 chains you want to deploy this on, the most obvious distribution would you would have $1 million on each of those 10 chains. However, you're limited by you can only really do $1 million in one go, in one transaction, which obviously is a lot, but for the sake of argument. But if you go to the liquidity layer, you have $10 million you want to deploy. You can instead keep all of those $10 million on Solana, meaning all of a sudden you've 10x the size of transaction you can do, and of course you don't have to rebalance. So you can actually be doing $10 million every 15 minutes, assuming the source transactions are coming from Ethereum. If they were coming from an Avalanche or a Solana, for example, you could do even far more volume as a result. Of course, this is powered by both Wormhole and Mayan, but as you can see, we've already got quite a few teams using this in some way. Either it's powering in-wallet bridging, for example, I mentioned Phantom and Backpack earlier, but also aggregators like Socket and LiFi are using Wormhole Settlement specifically to obviously allow for very large size transactions, but also speed and asset coverage. With lots of other bridges, you don't really necessarily have a way to bridge between Sui and Arbitrum, for example, or Arbitrum and Solana. And so Mayan and Wormhole are doing a lot to kind of make that a reality. I'm just going to go back to the other slide. Let's talk about kind of, what can you achieve with this? Now, the first and foremost thing, of course, is a cross-chain swap. If you've used Portal Bridge, if you've used a wallet like I mentioned, you've probably already done this. You go from one asset on one chain to one asset on another chain, and it doesn't have to be the same asset. It doesn't have to be the same chain, and in fact, it doesn't even have to be the same VM. So of course, with Wormhole Settlement, you can do a 10-second cross-chain swap between Ethereum and Solana and back, and very soon we'll be launching support for other chains as well, just out of the gate. Most obvious application, if you look at, for example, LiFi, when I talk to people about, most people are like, well, bridging is probably the most meaningful use case. Not many people really care about cross-chain swaps, right? They really just want to go from USDC to USDC or USDT to USDT and so on. But actually, if you look at the data, even an aggregator like LiFi, for example, with Jumper, around 40% of all their volume is actually swaps as well as bridging. The other 60%, of course, is single asset to single asset bridging, but then 40% is from one asset to a completely different asset on a different chain. And so I think you'll see a lot more of this once people realize that, hey, I think there's still a bit of, like, I don't want to say fear, but people want to go from, the most logical asset, i.e. gas token, to another gas token, and then they will execute the trade themselves just to get the best pricing. But the way that these bridges are now built, we simply, for example, in the case of the liquidity layer, as well as Mayan Swift and MCTP, we simply use all the aggregators available and we choose the best price for execution. So on Solana, of course, most, if not all, the aggregation of Solana is done by Jupyter, in which case, if there needs to be a swap on the Solana side, we simply use Jupyter to execute that swap. Just to give you an example, when you're going in and out of USDC, obviously we, or the solver, isn't necessarily doing the swap themselves. We simply tack on an aggregator call from the USDC to the asset that the user wants. And so, of course, on Solana, that's Jupyter. On EVM, it's usually Uniswap Universal Router or 1inch or something like that. And then, of course, on Avalanche, there is only one DEX, so we primarily use Trader Joe for all the Avalanche-based swaps. Then we have a very, very big, I guess 2 integrations or 2 applications, but you could kind of make the argument they're one and the same, and that's swaps plus actions. So I mentioned earlier, you can do things like you can send arbitrary payloads in these bridging transactions, meaning, let's say you want to go from, i.e., you want to go from ARB to Joe on Avalanche. What you can do, but you want to do that because, for example, there's like a Joe vault, or there's a Joe LP pool that's paying a lot of incentives. And so the whole reason why you're bridging to that chain and swapping into that asset is because you want to do something on that chain, for something very specific. And so in this case, you could actually send an arbitrary payload with the transaction when the user initiates it, such that once the Joe is received on the destination side, it can actually be batched with, say, a vault deposit call, and then deposit that directly into the vault. Now, what that means is you can actually do things where, you kind of batch it into the UX. Now, this is something that wouldn't necessarily be initiated from the bridge side, but let's say you have a vault on Solana that accepts USDC. You want to be able to attract, or rather, I don't want to say advertise, but allow any kind of user who has any asset on any other chain in order to be able to deposit it into that USDC vault. Now, of course, originally you'd have to tell the user, hey, figure out a way to get USDC on Solana, and now you can deposit. However, with settlement and the swap plus action functionality, you could actually change the front end of that USDC vault and be like, hey, if you've got any asset on Arbitrum or any asset on Avalanche, you can actually deposit into this USDC vault. And what would happen in that example is that same bridging flow would take place where, all of these things take place. It then emits the asset that the user wants, and then you tag on, for example, in that vault, the deposit call. And so all of a sudden, you're able to attract, any kind of user who has any kind of asset just out of the gate. Whereas typically, lots of vault products, especially on the EVM side, or on the ETH side specifically, they might have vaults live on mainnet on Ethereum. But then there's a lot of activity on Base. There's a lot of activity in Arbitrum. And so there'll be protocols that go live on those chains that will suck up a lot of the users and liquidity of people using that chain specifically. However, in this case, and so as a result of that, the original protocol would have to then deploy a vault, or deploy contracts on other chains in order to tap into those users and that liquidity. However, with this, you don't have to actually deploy on all these different chains. You can simply just give the functionality for the user to be able to deposit and redeem as if it was a same chain interaction. And that's one of the things that we're able to kind of power with Wormhole Settlement. There's a really good example here where you can also kind of, I mentioned that chain abstraction and the swap plus action are kind of one and the same. So this is an example. So Lulo Finance, for example, we actually worked on this thing together where you could have, so for context, Lulo Finance is a lending aggregator that is native to Solana. They're not EVM at all. They're only live on Solana, and they aggregate lending markets like SolLend, like MarginFi, like Camino, so on and so forth. with Wormhole Settlement, you could actually utilize a MetaMask wallet, an EVM native wallet, in order to execute transactions and in order to deposit things on Solana. So I don't want to play the video because it's quite a long video, but as you can see, this is Lulo Finance. You can do a bridge deposit, as we called it. Use MetaMask, which of course is an EVM only wallet, to then execute transactions on the Solana side. And so this person is trying to deposit, into the USDC Sol market. I'm assuming on Camino or something. And what's happening is they're actually using ETH to deposit into that vault. And you can see the deposit amount is actually 241 USDC, even though they're using ETH on Ethereum. However, the vault on Solana, or rather the lending market on Solana, is receiving USDC on Solana. And so this, of course, is a very, very small example. But if you were to kind of extrapolate this outward, any kind of protocol and any chain would be able to have this functionality built in, and you could have a lot of customizability over what the UX and the UI experience actually looks like, and you can make it so that you could make it so that a user doesn't even know what chain you're on, right? You give any kind of user this functionality, they're simply using a protocol, and that's it, which is something that's very, very exciting about Wormhole Settlement, that you'll be able to do with it out of the box. So that's kind of just if I'll go through the questions again before I move on. Nope, no new ones, which is good. But yeah, that's kind of the long and short of Wormhole Settlement. It's I'll go into the docs very quickly now as well. Oops. So of course you can go to either the Wormhole product page. So if you go to wormhole.com/product/settlement, you got to go to the product page and you can access it through the home page. And then if you want to check out the docs, you can go to wormhole.com/docs, and then you'll be able to find Wormhole Settlement quite easily. I won't go too deep into how to actually integrate the product, but of course, feel free to ask. But it is extremely simple. Protocols have been able to integrate it within an afternoon, and they all of a sudden have cross-chain swaps enabled out of the gate. Now, of course, if you want to do more esoteric kind of integrations, i.e., you wanted to integrate the chain abstraction piece, you wanted to do swap plus action, that would require more development. However, for the most part, it's an extremely easy just SDK integration. There isn't any custom work required. It's simply using the basic TypeScript Wormhole SDK. So yeah, I'll stop there. Very exciting protocol. Lots of interesting things you can do with it. Feel free to have any other questions that I can answer. Let's see. How exactly does consolidating liquidity on a single chain, Solana, mitigate traditional issues around liquidity fragmentation, and what trade-offs does this approach introduce? So mitigate traditional. So the biggest thing is rebalancing. When you're a solver, I'll actually bring up the architecture. It's a good one. Let's use this one. When in the Mayan Swift example, and like most intent-based bridges, the solvers have to rebalance because, of course, the inventory is getting imbalanced as transactions are going from one chain to another, and usually bridging isn't bidirectional, right? You can't net out just by letting it run enough times. What will happen most likely is some chains will receive a lot more activity and inflows than other chains will, in which case you have to execute rebalancing, which is extremely costly and time inefficient, which can lead to downtime. So I'll give you an example. During the weekend where Trump launched the Trump token, what happened was you saw billions of dollars flow from other chains into Solana over the weekend. I think Wormhole alone, or Mayan Swift alone, did something like $500 million over the weekend, and Wormhole did over more than $1 billion over 2 days. So as a result, pretty much every intensive bridge on the market was running into insolvency issues where I shouldn't say solvency issues, that implies something a bit different. But they didn't have any inventory, and because they would be constantly facilitating this bridging, and they'd have so much liquidity on the Ethereum side and then nothing on the Solana side because it's getting depleted almost instantly. And so these solvers would have to keep going back and forth to Binance. And what would happen is by doing so, they have to wait, let's say 20 minutes in order to rebalance. And then, of course, they can't facilitate any volume. And hence, like, volume goes to a different bridge that is able to facilitate it, even if it's slower or more inefficient or more costly. With the liquidity layer, however, I'll go back to the deck actually. With the liquidity layer, however, of course, because you don't have to rebalance, effectively is rebalancing all the time once the CCTP message kind of comes through. The solvers don't have to rebalance. And so to give you context, with $5 million in a typical intense architecture, you can do maybe something like around like $50 million in daily volume with $5 million in liquidity, which of course is split across multiple different chains. And yes, you can optimize it based on flows, but of course you're going to run into rebalancing issues, which can take time. And especially if it's time that's really volatile, i.e. like that weekend where the Trump token launched, even Binance will have problems. And if they arbitrarily disable withdrawals, the solver's kind of out of luck. Yes, if you're a very big solver, you can then, you have an enterprise account or what have you, you should be fine. But if you're a small solver and you're just using the basic, Binance account, for example, using Binance as an example, you're kind of out of luck. There's not really much you can do. And as a result, because of that, a lot of solving is actually only done by really big market makers. Because if you're a small fund or a small team, you can't really compete with them just because it's based on the amount of liquidity they have. One of the really interesting things that we really wanted to do with the liquidity layer is that it's completely open source. Anyone can become a solver. And we actually have an example solver repo on GitHub that you don't even have to build your own solver. We've actually done all the work. You just have to implement it and seed it with money, with USDC. Now, of course, it does require some technical capability. You need to understand how to land transactions in Solana. You need to be able to bid on these auctions and all the rest of it. However, one of the best things of this is because there is no like active rebalancing required, anyone can theoretically become a solver. They don't have to be whitelisted. They don't have to be permissioned. It's completely open to anyone, which is that was quite a long answer, but hopefully that answered all of them. I think the biggest thing, it's the last question about trade-offs that the liquidity layer architecture kind of introduces is that you are limited by CCTP, right? If CCTP isn't deployed somewhere, you cannot deploy the liquidity layer there. If, for example, they don't even have native USDC, you can't necessarily deploy the liquidity layer there. So that is probably the biggest limitation. You can't just deploy on every chain everywhere all at once like you'd like to. You are limited by that. But yeah, thank you for that. Let me what protections are built into Wormhole's liquidity layer and Mayan protocols to prevent malicious replay attacks or MEV exploits? So for the first one, it's purely based on escrow. So like I give the example earlier. I know you asked this question a while ago, but escrow is used very heavily. And what that means is that when the initial transaction is initiated, those assets don't go straight to the solver. They actually go to an escrow contract. And that escrow contract cannot be given to the solver unless it receives confirmation that the user has received, or the user wallet has received the assets that they requested. And only by doing that will the solver on the source chain be able to actually receive those funds. Otherwise, they won't leave the escrow contract, or they get reverted and given back to the user. As for MEV, on the actual bridging itself, MEV isn't really necessarily a problem. Now, where MEV is a problem is when it comes to the swaps in and out of the facilitation assets or the inventory assets. So if you are to say, theoretically, you can go from any asset to any asset as long as there's a liquidity pool on any DEX that's supported by the aggregators we use. Now, if that pool has very, very low liquidity, then you will be subject to MEV attacks. You will be subject to very, very bad price slippage and price impact. But that's the case even if you were to swap same chain. So we kind of outsource that, and we kind of rely on the aggregators themselves. So Jupiter, of course, their entire business is kind of built on minimizing this. Same with the Uniswap universal router. So we ourselves don't necessarily kind of optimize the pricing. We simply use whatever's available on those chains. And the reason for this is that we want to kind of execute as best as we can possibly on the whole auction setup. We don't want to necessarily kind of vertically integrate the entire stack because then we're competing directly with the likes of a Jupiter or a Uniswap or a 1inch, etc. So hopefully that answers your question. Chunwei asked, why not go from ARB to AVAX using CCTP? Well, you could. You could. In that example, you could swap ARB into USDC and then use CCTP to send it from Arbitrum over to Avalanche. And then once you have USDC on the Avalanche side, swap it into AVAX or Joe, whatever asset you want. You can do that completely. However, you have to wait 15 minutes, right? You have to wait for ETH finality. As we're finding out more and more, users are trending towards wanting speed above all else, especially if it's a small amount of money. Let's say there's an NFT you want to mint, or I don't know, there's something that you want to do on another chain, and you don't want to necessarily send tens of thousands of dollars. You're only sending $100 or $300 or $50. Those kind of transactions don't necessarily need or want 15 minutes of delay. They want to be done as quickly as possible. In which case, you would use the liquidity layer to get to that chain as quickly as possible. If you can wait, if you don't have any rush and you want to just wait 15 minutes, then feel free to use CCTP, but this is more for the users that want their assets on the other chain, as quickly as possible. The second question, are the solvers on Solana? So for the Mayan Swift, the solvers are, of course, everywhere. However, on the liquidity layer, yes, the solvers are specifically on Solana. And so the idea is that these solvers, instead of them having to have these solver contracts everywhere, they need to have inventory everywhere. They only need to basically look at auctions on Solana, and that's where they have their liquidity as well. They don't need to distribute it everywhere. So hopefully that answers your question. Can you clarify how intents differ from traditional cross-chain swaps and how Wormhole ensures the accurate execution of user intents? Yes. So, I did kind of gloss over the definition of intents. Intents now, I will say, are kind of synonymous with bridging, right? People kind of use intent and bridge as the same word. But yes, fundamentally, an intent is actually pretty much anything a user wants to do. And the idea is that you have a solver, you have a third party that does whatever it can to facilitate that initial intent. So to begin with, I think the most widespread use of intents, of course, is bridging, right? You have an asset on chain A and you want an asset on chain B. Typically, you would have to do you would have to swap, you'd have to find a DEX to swap on, you would then have to bridge from one asset to another, and you can only bridge an asset that would have liquidity on both sides, and then you have to, of course, swap from the asset on the destination chain to whatever asset you want. You would need gas on both ends. And so the idea is that with intents bridging, all of that gets abstracted away, and it's kind of taken out of the hands of the user. The user just says, I want this asset and I built this. And so all those things I just mentioned are kind of collapsed into just one UX, which is the actual intents bridge. But yes, that's kind of where the answer the fundamental basis of the question. That's kind of where the chain abstraction and the swap plus action comes in, where a user might not necessarily want an asset on another chain. They simply want to be earning yield from this USDC vault on Solana, and they've got a bunch of these random assets on these random chains. How do you kind of consolidate them all, bridge them over to Solana, and deposit them into that vault? And that is where the swap plus action functionality in Wormhole Settlement comes in, and where the chain abstraction piece comes in. And to answer your question on how does Wormhole ensure the accurate execution of user intents, specifically on the bridging piece, once the user receives the money that they requested or the tokens they requested, that emits a VAA, which is observed by the escrow contract on the source chain or on Solana. In which case, only once that transaction is confirmed by the VAA will that escrow then release the funds to the solver. If it's not completed, let's say it times out, the price isn't executed, what have you, then that transaction is reverted and the user simply gets the funds from the escrow account. In which case, yes, they might have used Solana or they might have used like some token to begin with, and they want another token. So they would just get redeemed. They would get refunded, ETH, or they get refunded USDC, most likely USDC. So it's not ideal, obviously, but the idea is that if it's not executed, you at least just get stable coins back that you can then just reinitiate the transaction or do whatever you'd like. How does Wormhole handle settlement failures or inconsistencies between source and destination chains? I guess kind of the answer to this is the escrow piece. Is that until that transaction is validated, in that the user receives what they wanted, or the smart contract vault or what have you receives the assets that was requested, only then will the initial funds be released to the solver. Otherwise, the solver never receives those funds because the transaction was completed successfully. How many different solvers are there? One per ecosystem? No, it can be a handful. Certain chains might only have one solver. There'll be solvers that optimize simply for one chain, i.e., a solver that only is really interested in facilitating flows to and from Linnea. There'll be other solvers that are more generalized, where they'll just be everywhere on every single chain possible, and they just want to have as much breadth and widespread coverage as possible. Then you'll have some other solvers that are actually only interested in like the big five chains, right? They only want to do solving between ETH, Solana, Arbitrum, Base, and Optimism, and they don't really care about any of the other chains. And so, it is honestly completely it is arbitrary. It's just, if this obviously solving is one of the most revenue generating things that market makers do, and so most of them want to be everywhere, but it's completely up to them at the end of the day. Yeah. Hopefully, I was able to answer all of your questions. If there's anything else you'd like me to touch on, feel free to ask. Otherwise, thank you for having me.
Hello again. Thank you so much. Thank you for everyone's questions. Thank you, Sushant, for the workshop and going through everything so well. As I said, we'll be posting this video very soon. So if you missed anything or want to go over anything again, we'll post it where we usually post these things and you'll find it. So yeah, have a lovely rest of your day, everyone. And if you celebrate Easter or off the next couple of days, enjoy your long weekend. And we'll see everyone very soon. Bye-bye.
Thank you, everyone.
Bye.
Take care.
Bye-bye.